Okay, ma? So the next topic which we are starting is Ionic Equilibrium. Ma? So we have studied chemical equilibrium now. Now we are discussing about Ionic Equilibrium. So first of all we will study the basics of this, then we will enter into the main topic. Ma? So acid-base theories. You should have studied them previously, no? How many acid-base theories are there? First one is called as Arrhenius Theory. Second one is called as Bronsted-Lowry Theory. And the third one is called as Lewis concept of acids and bases. Okay, ma? So these three people, they give theories on what is meant by an acid and what is meant by base. So most all the theories, they are satisfied in different molecules. Are you able to understand? So first of all we will study about the first theory which is called as Arrhenius Theory. Okay. So what is meant by Arrhenius Theory? He said that acid, what is meant by acid? Acid gives H plus ions in water. Okay. So anything which gives H plus ions in water is called as acid. That is the definition of acid according to Arrhenius Theory. Are you able to understand? It means acid, if you put in water, immediately it releases H plus ions. And what is meant by H plus ion? H plus ion also you can call it as a proton also. Okay. H plus ion you can call it as a proton also. Why you can call it as a proton? Because in hydrogen we have only one electron. No? So if that one electron is removed, now what is the remaining thing in that one? Only nucleus is present. Are you able to understand? And in that nucleus what is present? Only one proton is present. So therefore H plus ion you can call it as a proton also. Okay. So this is the definition of an acid according to Arrhenius Theory. Then how can I define a base? What is meant by base? Base means it gives OH minus ions in water. So this is the definition of base according to Arrhenius Theory. Are you able to understand? So if you want to write some examples, what are the examples you can write? For example, you take HCl. Okay, ma? It dissociates into H plus plus Cl minus. Okay. So this is what happens when it is some water is added to this one. Are you able to understand, ma? So it is giving H plus ions. H plus ions, if it is giving, then is it an acid or is it a base? So this one I can call it as an acid according to Arrhenius Theory. Are you able to understand? Similarly, if I take NaOH, okay, then it can dissociate into Na plus and OH minus. Clear, no? So therefore it is giving OH minus ion. So if it is giving OH minus ion, then this particular compound I can call it as a base. So this is the definition of base according to Arrhenius Theory. Are you able to understand, ma? But here there is one problem. Okay, ma? Note point is that so H plus ions cannot be present individually, in water. Are you able to understand, ma? So H plus ions, they cannot exist individually inside water. Are you able to understand? So therefore Arrhenius again gave another theory which is called as modified Arrhenius Theory. He modified this statement and he gave a modified Arrhenius Theory. Clear? Make a note. Okay, ma? So therefore H plus ions, as they cannot exist in water individually, Arrhenius gave a modified theory of his own theory which is called as modified Arrhenius Theory. Are you able to understand, ma? So see. So according to this modified Arrhenius Theory, what is called an acid? Okay. So which gives hydronium ions in water is called as an acid according to modified Arrhenius Theory. Okay. What is meant by hydronium ions? Let us see. So H plus, when it reacts with the water, it forms what? It forms H3O plus. And this is exactly what is called as hydronium ion. Are you able to understand, ma? So acid, it releases H plus ions, no? Acid should release H plus ions. But these H plus ions, they cannot be present individually inside water. They will react with water. And once they react with water, what is the compound which is formed here? This is called as an hydronium ion. Are you able to understand, ma? And in some of these cases, this H plus, it can react with the two molecules of water also. Okay. So for that, how can I write the reaction? I can write H plus 2H2O, it gives rise to H5O2 plus. Okay, ma? So this is another type of reaction which can be formed. Are you able to understand? So therefore, H plus always reacts with water to form hydronium ion. So whatever compound which is forming this hydronium ion, this can be called as an acid according to modified Arrhenius theory. Are you able to understand, ma? And then what about base? Okay, ma? So base concept remains the same. For the base, the concept remains the same. What is meant by concept remains same? It gives what? It gives OH minus ions in water. Are you able to understand, ma? So this is called modified Arrhenius theory. Just H plus it reacts with water to form hydronium ion. That's it. Are you able to understand, ma? So the next theory which we'll study is Bronsted-Lowry theory. Okay, ma? Next theory is called as Bronsted-Lowry theory. Okay. So according to this theory, what is called an acid? Okay. Which donates H plus ions is called as an acid. So I am writing everything in short form. I hope you can understand, no? Are you able to understand? So anything which donates H plus ions is called as an acid. Are you able to understand? And what is the definition he gave for base? Okay, ma? Which accepts H plus ions is called a base. Okay. So in the case of Arrhenius theory, separately we have studied H plus and OH minus, no, ma? So which gives H plus is called as an acid, and which gives OH minus is called as a base. But in the case of Bronsted-Lowry theory, everything is defined only on the giving and taking of H plus ions only. Which gives H plus is called acid, and which takes H plus is called as base. So this is the definition according to Bronsted-Lowry theory. Are you able to understand, ma? For example, again we can take the same example, ma. So HCl, a door lo open ayunnara. Madam ne vilu sir. Sir, madam ne vilu. Okay, ma? So HCl, it gives rise to H plus Cl minus. So therefore HCl, what you can consider? Acid, no? Why? Because it is giving H plus. Are you able to understand, ma? So this one, I can call it as an acid. Okay. Similarly, if I take NaOH, okay, ma? So if you do the electrolysis of this NaOH, then it gets separated into ions, no, ma? It gets separated into Na plus OH minus. This is what happens. This is how they get separated into ions, no? Na plus and OH minus. Okay. Now this same NaOH, if it is put in water, okay, ma? Then it converts into Na plus and H2O. So this is what is happening in this reaction. Okay. Now can you say what is happening in this reaction? Anybody, can you say? So here OH minus is present, no, ma? Actually this is the reaction if I electrolysis this one. Okay. And OH minus, it is converting into H2O. How it is possible? So this OH minus, it converted into water only when it has accepted H plus ions from water. Are you able to understand? Because OH minus plus H plus, what it will give rise to? It will give rise to H2O. Are you able to understand, ma? It means here NaOH is accepting what? NaOH is accepting. Okay, ma? So understandable, ma, what is happening here? So this OH minus, it takes H plus from water, and therefore water is again formed here. So therefore NaOH, is it releasing H plus or accepting H plus, ma? Accepting H plus. So therefore this one I can call it as a base. According to which theory? According to Bronsted-Lowry theory. Are you able to understand, ma? So this is called as an theory of Bronsted and Lowry. Clear? So I hope you can, if you write like this, you can understand, no, ma, what is happening. No need of writing statements, no? Okay. So similarly, next we will write about acid-base conjugate pairs. Okay, ma? So acid-base conjugate pairs. So this concept was also developed by Bronsted and Lowry itself. Okay. So the concept of acid-base conjugate pairs. Okay. So let us see what is the meaning of this one. So between an acid base and its conjugate base or acid, there should be a difference of one proton. Okay, ma? Then such pairs you can call them as acid and its conjugate base, or you can call it as a base and its conjugate acid. Are you able to understand, ma? So in between them, what should be the difference, ma? Difference should be one proton. One proton means what here? One H plus ion should be the difference. This is called as acid and its conjugate base, or you can call it as a base and its conjugate acid. Are you able to understand? So see here I have written acid, ma, and here we have a conjugate base. Clear? Here I have written base and here I have written conjugate acid. That is the meaning of this one. Okay. For example, let us take the same example of HCl, ma. For example, HCl, it disintegrates into H plus plus Cl minus. Okay. Now HCl is what? HCl is definitely an acid, no, ma, because it is giving H plus ions. Are you able to understand? And if you see this Cl minus, this one I can call it as a conjugate base. Okay. Now can you say why I am calling this one as a conjugate base, ma? Because if you see this HCl and Cl minus, what is the difference between them? Difference between them is one H plus ion, no? It means one proton is a difference. So if there is a difference of only one proton, then such pairs you can call them as acid conjugate pairs. Are you able to understand? So therefore, in between HCl and this Cl, there is a difference of, okay, ma, one proton. Okay. So this one will form acid and its conjugate base pairs. Are you able to understand? Clear, no, ma? Shall I take one more example? Completed, no, this side? If I take one more example, let us take carbonic acid, ma, H2CO3. Then this can disintegrate into H plus plus HCO3 minus. So it can disintegrate like this. Are you able to understand? Now here this is carbonic acid. This is an acid. Why you can call this one as an acid? Because it is giving H plus ions, it is giving a proton. So definitely you can call it as an acid. Are you able to understand? Now if this is an acid, then can you say, will it become its conjugate base or not? Definitely it will become conjugate base. No, why? Because there is a difference of one proton. Are you able to understand, ma? So therefore, these two, I can call it as an acid conjugate pair. Are you able to understand? So this is the acid, and what is this one? This is a conjugate base. Is it clear? Because again there is a difference of one proton. Similarly, this HCO3 minus, again it can disintegrate into H plus plus CO3 2 minus. So it can disintegrate like this also. Are you able to understand, ma? Now this one is what? This one and this one, again they will form one acid conjugate pair. Okay. Are you able to understand, ma? HCO3 minus, now is it an acid or a base? Acid only. Why? Because it is releasing one H plus, so definitely this is an acid. Are you able to understand? And this one? Conjugate base. Conjugate base of what? Conjugate base of HCO3 minus. Are you able to understand, ma? And they are forming a pair because again there is a difference of one proton. Okay, ma? Similarly, if you take H2CO3 and CO3 2 minus, these two also, can I call them as acid conjugate base pairs or not? No, why? So there is a difference of two protons, no, ma? Okay. So to H2CO3, to reach up to CO3 2 minus, it should release two H plus ions. So therefore this you cannot call it as a acid conjugate base pair. Are you able to understand, ma? Difference should be how much? Difference should be only one proton only. Okay. So therefore this one I cannot call it as a acid conjugate base pair. Okay. So what is the reason? Because a difference of two protons is existing. Are you able to understand, ma? Clear, no? Similarly, in chemistry you should have studied about aniline. Have you studied aniline, ma? What is the formula of aniline? Benzene ring with NH2. Clear, no, ma? So this is an aniline, no? So this you can call it as NH2. Are you able to understand? So this one, if it accepts one H plus, then what it will form? It will form NH3 minus. This is the reaction which will happen. Are you able to understand? Ma? Now this one is what? Is this one an acid or a base? Huh? It is accepting H plus, no? It is accepting one proton. If it is accepting one proton, can you call it as an acid? You have to call it as a base. So this is a base. Okay, ma? Now what is this one? Conjugate acid. Why you can call it as conjugate acid? Because there is a difference of one proton. Are you able to understand, ma? So this one I can call it as conjugate base. Now understood, ma, what is happening in this condition? Clear, no? So there should be a difference of one proton. Then you can call them as pairs. One acid and its conjugate. So this is its conjugate acid. Are you able to understand, ma? That's it. Make a note up to here. Okay, ma? So next we study the concept of third theorem, which is called as Lewis concept of acids and bases. Okay. So therefore, according to this concept, what is called as an acid? Which accepts a lone pair of electrons, then you can call it as an acid. Okay, ma? It is not accepting single electron, it is accepting lone pair of electrons. What is meant by lone pair? You should have studied in chemical bonding, no? What is meant by lone pair? Lone pair means what? Those electrons which doesn't participate in bonding, but they are present in the outermost orbital. So such electrons you can call them as lone pair of electrons. Are you able to understand, ma? So any compound, when it accepts a lone pair of electrons, then you can call it as an acid. Okay? And what is the exact opposite definition of the base, which denotes a lone pair of electrons, is called as a base. Are you able to understand? Okay. Now if you see, in which condition acid can accept a lone pair of electrons, ma? Can you say the condition? Huh? There should be deficiency of electrons, first point. It means its octet is not filled. Are you able to understand? Similarly, you can say, the orbitals are vacant. That is the condition only in which an acid can accept a lone pair of electrons. Understood, Nama? So what is the first case? First case should be octet is not completed. Okay, ma? I am saying you this because when solving problems, these are the properties you have to check. Which one is an acid and which one is a base, you can see from these characteristics. Are you able to understand, ma? If it is able to accept electron, it means its octet is not completed. For example, neon, can it accept a lone pair of electrons, ma? Because its octet is completely filled. Are you able to understand? So octet should not be completed, and it also means that there is some vacancy in orbitals. Are you able to understand? If there is some vacancy in the orbitals, then only it can accept a lone pair of electrons. Because if vacancy is not there, if it takes the electrons, where it will keep? Okay, there should be some vacancy present in the orbitals. Okay. Now what is meant by base? Which denotes? Donates, not denotes. Which donates. Clear, ba? Which donates a lone pair of electrons is called as an base. Clear? And for donating, can you say what are the conditions which are possible, ma? First of all, octet should be completed, no? Octet should be completed. Octet means what? 8 electrons should be present in the outermost orbital. Octet should be completed. And there should be one extra lone pair of electrons. Clear, Nama? There should be a lone pair of electrons. Okay? So these are the conditions in which compounds can behave an acid or compounds can behave like bases. Are you able to understand? Now let us take some examples of this. Completed, ma? For example, if I take example of NH3, okay? NH3. Now I have to check it whether it is behaving like an acid or whether it is behaving like a base. Are you able to understand, ma? So what is the electronic configuration of nitrogen? 1s2, 2s2, 2p3. This is the electronic configuration, Nama. It means how many electrons are present in the outermost orbital? 5 electrons are present in the outermost orbital. Clear, Nama? But it is forming a bond with how many hydrogen? 3 hydrogen. Are you able to understand? What about the remaining 2? So octet, is it completed? Okay, ma? So here I have 2 plus 3, 5. 5 plus 3, 8. Octet, is it completed or not? Octet is definitely completed. Are you able to understand? So hydrogen is giving its 1 electron means what? Sharing of electrons, no? So sharing also you can call them as completion of octet only. Actually they are forming bonds only to attain octet configuration. That is the purpose of chemical bonding, no? Are you able to understand, ma? So therefore there are 5 electrons in outermost orbital. Are you able to understand? Outermost shell. And what about this 3? 3 electrons are additionally given by hydrogen. They are shared between hydrogen and nitrogen. So definitely you can say octet is completed, no? Octet is completed. Are you able to understand, ma? Octet complete ayindara ikkada? Octet is completed. Sir, alochinsandi. Okay, ma? And is there any lone pair of electrons or not, ma? Lone pair leda? Lone pair of electrons, is it present or not? Yes. So this is the lone pair of electrons, no? So definitely they are present in the outermost orbital. 2s2. But these 2 electrons, are they participating in a chemical reaction, ma? No, they are not participating. It means there is a lone pair of electrons. So therefore this NH3 behaves like what? This NH3 behaves like a base. Why it behaves like a base, ma? Because first of all, what is the property we have studied in the case of Lewis theory? It should be able to donate a lone pair of electrons. So there is an additional lone pair of electrons, no? So definitely it has the ability to donate these electrons to another compound. And its octet is also completed because it is forming a bond with 3 hydrogen atoms. Are you able to understand, ma? So therefore this is the structure I can draw, no? Okay, one bond with single bond with all the 3 hydrogen atoms. Are you able to understand, ma? So therefore here there is 1 electron, here there is 1 electron, so both of them they are getting shared here. So here there is an electron, here there is one more electron, these 2 are getting shared with each other. Here there is an electron, here also there is an electron, these 2 are getting shared with each other. Okay, so total octet of nitrogen is completed, so it has become stable. Are you able to understand, ma? And additionally there are 2 electrons in 2s2 which are not taking place in chemical bonding. So therefore they are the lone pair of electrons. Are you able to understand? So that is the reason why base behaves, this NH3 behaves like a base. Is it clear? Okay. Similarly, let us study one more molecule, ma. Completed writing this one. Let us study about Bf3 molecule. Bf3 molecule. Are you able to understand? Now try to study this one. Check whether it is an acid or a base. What is happening here? Acid. How can you say? No lone pair of electrons. How can you say there is no lone pair? Octet is not completed. Sima. So what is the configuration of boron, ma? So it is 1s2, 2s2, 2p1. This is the configuration, no? Are you able to understand? And it is reacting with how many fluoride ions? It is reacting with 3 fluoride ions. Are you able to understand? It means in the outermost orbital, how many electrons are there, ma? So this is first shell, this is second shell. In the second shell, totally how many electrons are there? 2 plus 1, 3 electrons are present. And all the 3 electrons, they are being shared with fluorine. So there is no lone pair. Lone pair is not present here. Okay, lone pair means what? That pair of electrons which are not participating in chemical reaction, they are absent. Okay, so therefore definitely this one cannot behave like a base. And octet, is it completed, ma? Octet, is it completed? So 3 electrons in second shell reacting with 3, combining with or shared with 3 electrons of F3. So total 3 plus 3, only 6 electrons are present. So there is a vacancy for 2 electrons. Chemical bonding lo ivanni chadivaru kada, mari endu face lo petnaru? Arthamaindi kada concept. Okay, ma? So therefore here what I can write, only 6 electrons are shared totally. Okay, ma? So there is a vacancy for lone pair. And also I can say octet is not completed. Octet is not completed. Okay, ma? So therefore Bf3, it behaves like an acid. Okay. So therefore if I put NH3 and Bf3 at one place, which one will give lone pairs, which one will take lone pairs, ma? So this will give the lone pairs, that is why it is called as a base, and this one will receive the lone pairs. Are you able to understand? Because it has a vacancy for accommodating those 2 electrons in its outermost shell. Are you able to understand? So that is why this is the concept of Lewis base theory. Which one is called as an acid and which one is called as a base. Are you able to understand? So therefore, if I take this boron, okay, so it will form single bonds with fluorine. Are you able to understand? So totally how many electrons are present in outermost orbital? 3 electrons are present. So here there is 1 electron, another electron, and this is another electron. So fluoride also will give 1 electron. Are you able to understand, ma? So therefore, this is the type of bonding which is formed here. Are you able to understand? That's it. Make a note.